So it's my turn now. Okay. Hello, everyone. What a great group of mathematicians. Welcome, everyone. My name is Isabella Spiech, and I'm with Math Kangaroo in US for over 20 years. But my journey with this competition started much earlier when I was still living in Poland. At that time, one day, my daughter, which was seventh grader at that time, she came back from school and she was very excited and she said, Mom, there is an international math competition, Kangaroo, and guess what? Everybody can compete. And the competition is 1 week, which means we had 7 days to prepare, but we couldn't because there were no sources for any materials to get ready, to get familiar with the questions. So 1 week later, she came back from school and she said, well, it was hard. And I'm not sure if I'm good in math anymore. And I read the questions and I thought about myself almost the same. But we sat together. The good thing was, she said, but can I compete one more time next year? So it was promising. And then we started to work on the questions, and very soon we find them obviously challenging, but only because they were quite different from the questions that was presented at school and actually which are presented at school on regular basis, because simply teachers don't have more time for doing more than they can and have to. And it was really, really excited for us. And in no time, we discovered that it's a great competition with great questions and everybody can work on them and be ready for the future competition as well. As I've noticed, we had 1 week to prepare without any materials, but now with the access to Math Kangaroo practice materials, it's so much easier to be prepared and become a champion. We have tests from previous years to practice, Math Kangaroo practice exams, videos, webinars, and events like this, which I really appreciate. And I promise, when you start solving 1, 2, or 3 questions per day with your parents, siblings, or even by yourself, there is a chance you will be great prepared to be a winner. But besides, think about it, showing up on the test makes you a champion already, since you are brave and you know that you will benefit from the competition in many ways. Each participant receives the Math Kangaroo t-shirt and a small surprise gift just on the test, on the day of the test, because we just want to cheer you up a little bit. But the most important, you will gain math and logic skills, which will help you in the future, not only at school, but in your real life. So please ask your parents to read feedback we keep receiving from students, parents, and teachers on our website. They're presented on our website, and I believe you will find them very interesting. Each year, we recognize 20 top scores at each level, at each grade, actually. So there are 12 grades nationally and 3 top scores in each state. But when you we send prizes for winners to winners after the results are published after the competition. But when you keep taking the Math Kangaroo test year by year, which I believe you will, you not only excel in math, but also there is a chance you will be selected to go to the international math competition camp in one of European countries. Usually we send our participants to Poland when where there is only not math, but also many other interesting activities, like hiking and gaming and performing arts and making friends with other participants from all over the world for years. When you keep taking the Math Kangaroo test year by year and you are so persistent and you get to the 12th grade with great scores, there is a huge chance that you will be receiver of Math Kangaroo college grant. Still, the amounts are and the awarded students are listed on our website. I don't have much time and I don't want to take much time on this, but please go and check our website. As you probably know, the Math maybe not, the Math Kangaroo Association, International Math Kangaroo Association, was established in 1994. So how old is the competition now? Answer your question in chat panel if you want. It was a group of 5 countries which presented the Math Kangaroo problems for first test for hundreds of students from those countries. Now, the Math Kangaroo Association consists of 92 members from 92 countries, which ran the competition this year, 2022, for over 4 million students all over the world. Before pandemic, we had over 6 million students, and I'm convinced that that number will be reached very soon, or even overcome very soon. So if you registered for the 2023 Math Kangaroo competition, or you are going to be registered, you will become a member of the huge Math Kangaroo family of students from all over the world who solve the same set of questions at the same day, and the questions are translated for as many languages as many countries participate. Every year I found it very, very excited when I think about this, being with students at the site where they take the test, and I think that someone already took the test far away from US, or will take the test the next day because of the time change. For me, it's very interesting and exciting. Questions for 2023 competition has been already selected by the group of professors, math teachers, math enthusiasts on the yearly conference, which took place in Italy 1 month ago. And basically, we are ready to present them in March 2023. And there is no secret, I can tell it, that they are unique, intrigue, and some students find them even fun. And I believe that you will find and be satisfied, you will find pleasure and be very satisfied solving them in 2023. Registration for the Math Kangaroo is in progress until December 15th. You are very welcome to register if you weren't so far. And if you are a teacher or if you are a parent who wants to bring the math competition to the school or to the students from the community, you are very welcome to contact us and to set up the center. We are assisting our managers 24/7. So from day 1 until the end of the competition and beyond. And really, I will encourage you to show the students the other way to learn math. It's very interesting. I think now it's time to practice, and I won't take your time any longer. If you have any questions, I'm here to answer. Thank you very much, and enjoy the meeting tonight.
Thank you so much for that great introduction into Math Kangaroo. And just like you said, we are going to start going into some of the really cool problems that we found from a Math Kangaroo competition. And that would not be possible without our first TA, whose name is Kevin. And Kevin is really, really impressive. He has qualified for Amy since 8th grade, and he also made it past the USACO Bronze Division, and he's currently in the Silver. So that's computer science. And then in addition to all of that really cool academic stuff, Kevin's also good at sports, and he's on his school's varsity volleyball team. Kevin, I think you're muted.
All right, thanks. All right, with me here is Jesse. He's also an Amy qualifier. He got a perfect score on the AP CSA test. A perfect score on any AP test is very, very, very impressive. And he also has 2 cats.
All right, awesome. So without further ado, we are going to get into our problems. And for anyone who's new to these kind of live solves or the daily challenge classes, well, what we do is you can see on our chat, like on our screen, that we have this really cool chat system. And in order to get your messages on here, what you have to do is go on the Zoom and change your messaging to chat relay. And on there, if you send a message to chat relay, it'll show up on our screen just like this, and everyone can see what you're saying. So that's really cool. And let's get started. We're going to start off with 2022 Math Kangaroo grades 3 and 4, problem 2. And this says that if laser beams reflect in mirrors in the way shown in the first picture, at which letter will the laser beam in the second picture end? So let's take a look at our first picture. Well, we have these red lines to show us where they're moving. And it sees that if we're hitting a line that's angled like this, then it bounces straight down. And if the angle is like this, it'll go straight. And basically, it's going to go into one side from like up or down, and then it's going to bounce off to the other side. So let's track our laser right here. So if we're starting from the left, we're just going to bounce right down. If we bounce down, we're going to keep going to the right. And when we hit this right one, we're going to go up. Once we go up, we're now going to the right again. And now we're going to go down. Oh, it seems like we got a lot of people saying B. And yeah, if we keep going, then we hit this one right here. We go to the left, and then we go out of the cage, or we go out of the map. And when we end out of the map, we hit B. So I see lots of people sending in answers in chat, which is super amazing. You can see them all here. And everyone's saying our answer is B. So let's check it. And the answer is B. So great job, everyone.
Yeah, nice job. All right, now we're moving on to question 4. So we have, what is the smallest number of boxes that Bill has to move to be able to open the train box? All right, so this bottom one right here, this one is the train box. So let's see which ones are on top of it. So this one right here, the stuffed animals box, is obviously on top of the train box, so we'll have to move that one. This bedding one is also on top, so we'll have to move that one. This one right here, it says sheet music. That's on top of both bedding and stuffed animals, so we'll also have to move that. That's 3. This one, books, is above stuffed animals, so we'll have to move that as well. And then you see that this one, board games, is also on top of bedding. And the other 3 on the side don't really have to do anything with the train box. They don't touch, and they're not on top of it either. So how many boxes do we have? We have 1, 2, 3, 4, 5. So we have to remove 5 boxes to be able to open the train box. And that is, as everyone's been saying, choice C. Let's see if that's right. Yep, it's C. Nice job.
Awesome. And we're moving right along to question 6. And this question says that Anna makes a puzzle where 2 squares with common sides do not share the same number. Which piece should she use to complete her puzzle? So if we have this map or this kind of puzzle right here, then we need to fill out this space. And what do we know? Well, we know that they can't be the same numbers that are next to them. So this thing, this like square right here, well, it can't be 3 or 5. So let's check our answer choices and see, do any of them have 3 or 5 at the top? And we can eliminate them. Well, we have 4, 1, 2, 2, 3. Well, we just said we can't have 3 at the top because then it'd be the same. So we can get rid of answer choice B. Let's move on to the square right below it. Well, this square can't have a 1 or a 4. So now let's check our answer choices. The first one has a 1 there, so it won't work. The second one has a 3 there, it will work. Then we have a 4, which we said won't work. And let's say we have a 3, that does work. So now we're down to B and D, and we still got 2 more boxes to check. So our next one, it can't have a 5 or a 2. So let's see. The first one, which is answer choice B, has a 4 in it. And the last one, which is D, has a 1. Those both pass. Now we just got to check our last one. And we can't have a 2, 3, or a 5. So it can be any number except 2, 3, or 5 in there. So let's check. Well, B has a 2. Won't work. And D has a 4, which does work. And just like everyone is saying in chat, so great job on that. It's going to be answer choice D. Let's check our answer. It's D. Awesome.
All right. Question 8. John builds the tower shown. What will he see if he looks at his tower from above? All right, so you can see that the second one right here covers these smaller ones. There's actually 2 in the middle, but it's a little bit hard to see. So this big one covers the 2 smaller ones. So we won't be able to see the 2 of them down here. So we'll be able to see this top one because it's on the top. We'll be able to see the second one because it's bigger than the first one. We won't be able to see the third and the fourth because they're smaller than the second. And we will be able to see the fifth because that one's the biggest. So we can see 3 boxes. So this first one says that we can see all of them, so that's not correct. Second one says we can see 4 of them, that's also not correct. This one says we can see 3 of them, so that might be correct. This one says 2, that's also not correct. This one says 2, that's also not correct. So I think the answer should be choice C, and let's check it. Yep, choice C.
All right, now we have question 10. So we're going on. The ages of a family of kangaroos are 2, 4, 5, 6, 8, and 10. The sum of the ages of 4 of them is 22 years, and we need to figure out the ages of the other 2. Well, let's start by finding the sum of the ages of all the kangaroos. So if we were to take all 6 kangaroos instead of 4 of them, then the sum of the ages would be 2 plus 4 plus 5 plus 6 plus 8 plus 10. And if we added all of these numbers up, we would get, well, that's 10, that'd be 20, that's 30, and that's 35. So the sum of all of them would be 35. So if the sum of 6 of them is 35 and the sum of 4 of them is 22, then that means that the sum of the 2 that we're not choosing is going to be 35 minus 22. So we want the sum of our 2 remaining ages to be 13. And let's go take a look at our answer choices. The first one is 2 and 8. That adds up to 10, so that's not right. The next one is 4 and 5, which is 9. That's not right. C is 5 and 8. 5 plus 8 is 13, so it could be right. D is 6 and 8, which adds up to 14. That's not right. And lastly, E is 6 and 10, which adds up to 16. That's not right. So our answer here is going to be C, which is the only one where the ages add up to 13. So let's go ahead and check our answer. C, 5 and 8. Awesome.
Yeah, we've got a lot of C's today. All right, question 12. George wanted the sum of the 3 numbers in each row and in each column of the grid to be the same. He made one mistake. Which number must he correct? All right, so how about we just go through all 9 of these and then just find the sum of each row and find the sum of each column. So here we have a 9, a 1, and a 5. That gives us 15. Here we have a 3, a 7, and a 6. That gives us 16. We have a 4, 7, and a 4. That gives us 15. And then for the columns, we have 9, 3, and 4. That gives us 16. 1, 7, 7. That gives us 15. And 5, 6, and 4, which also gives us 15. All right, so they either all add up to 15 or they all add up to 16. Well, since we have 4 of them that add up to 15, I think that it might be the ones that contain the sum to be 16 to be wrong. So let's look at the 16. 934 and 376. Well, they both share this 3, right? So if we change that 3 to a 2, then this would be 15, and that would also be 15. So if we change 3 to 2, then it'll be 15. So I think the answer is choice B. And let's check that. Yep, choice B. Nice job, everyone.
Alrighty, so the next question says, Joanna is folding the number square twice as shown. Then she punches a hole through the black spot shown by the arrow. What numbers is she going to punch through? So actually, I happen to have a piece of paper next to me so we can kind of see this. So if we're starting with our square like this, then we fold it in half. Then notice that the piece that was at the top is now the piece that was at the bottom of the other side, right? Because if we open it up, we have the top and the bottom, and they match up. Now, if we were to fold it again, then we have the piece in the middle would match with the piece in the middle. Because when we fold it, that's how they line up. So now let's look at here. Once we have it folded twice, then we're going to have this middle piece punched out. So when we punch out the middle piece there, well, let's say that this square here with our 9 is going to be this bottom left square. So this is going to be 19, 20, 21, 25, 26, 27, 31, 32, and 33. So if this is our square like this, and we punch out the middle, then when we were opening it up again, then this piece is punched out, but so is this one. So that means that we're going to have 20 punched out and 23 punched out. And then if we opened it up again, then these ones at the top are the ones at the bottom now. So we have this 20 and the 23, but also the ones right above it. So 14 and 17. So the ones that are going to be punched out by punching out this one right here are 14, 17, 20, and the number that was right there, which is 23, right? We can see them here. 14, 17, 20, and 23, which goes with answer choice B. So let's check them. Looks like we got the right answer.
All right. Question 16. The cube in the picture is built using 3 kinds of wooden blocks shown. How many white wooden blocks are used? The cube in the picture is built using 3. Oh, okay. So we can see that. Okay, actually, this is really hard to see, but this one is gray. This is gray right here. That's the L shape. This one is equal to this one. This dark one is this one. So these two are the same. And these two are the same. And then the white one are just the rest of the little squares around. So let's think about it. We have one L. And how many squares does that take up? Well, if we split it up, we can see that it's 3. Okay, that is very hard to see. And that's white. Okay, so there are 3 you can see here. 1, 2, 3. And then the length is also 1, 2, 3. However, it contains 1 from the length and the width. So there's 5 blocks in the L shape. Then with this gray one, there are 2 blocks because you can just split it. Oh no, there are 3 blocks because it takes up this whole height right here. So that's 3. And then I see another gray one right there. And since the one in the middle and the one on the side are separate, I think that means we have 2 gray blocks because that means the one in the middle is like going straight through. So we have 1 L, which is 5 blocks. We have 2 of the gray ones, which is 6 blocks. And well, we have a whole cube here. And how many blocks are in a cube? Well, it's 3 by 3 by 3, right? So there should be 27 total 27 total cubes. So here we have 11, and we need 27. All right, let me get chat out of the way. We have 11, we need 27. So what is 27 minus 11? 27 minus 11 gives us 16, which is answer choice D. So let's check that. Wait, no. I did my math wrong, did I?
I think it was asking for the white cubes. And then the white ones would be the single blocks.
Oh, no. Sorry, I didn't see this one up here. This one is also an L shape. This is really hard to see. This one back here, this one in the very, very corner, that's also an L shape, because if you look at the actual test, this one's darker than the one right beside it. So actually, we do not have one L shape. We actually have two L shapes, which means that that is not 11 total, but 2 times 5 is 10, 2 times 6 is 11. So, or no, 2 times 5, this one is 10. This one we already calculated, 2 times 3, so that's 6. So that's 16 total. So 27 minus 16 is 11. All right, lots of funky math. Yep, 11.
All right, yeah, that was a pretty challenging problem to look at, like, because you got to see the blocks, right? There's no mathematical way to say which blocks are where. You just have to see them, which makes that one pretty cool. And if we go to our next problem, which is question 18, there are 3 football teams which participate in a sports tournament. Each team plays the other 2 teams exactly once. In each game, the winner gets 3 points and the loser doesn't get any points. If the game ends in a tie, each team gets 1 point. So at the end of the tournament, which number of points is impossible to have? Okay, so if we have 3 different ways to end the game, there could be a win, a loss, and a tie. If you win the game, you get 3 points. If you lose the game, you get no points. And if you tie, you're going to get 1 point. And in our question, it says that each team plays the other 2 teams exactly once. So everyone plays 2 games. Now, on each game, any of the teams could have any of these outcomes. So they could win twice, they could lose twice, they could tie twice, they could win and lose, they could win and tie, or they could lose and tie. And these are the 6 different outcomes that we have. Now, you could swap the order, but it doesn't really matter because it doesn't affect the point count. So why don't we calculate how many points that each team could end up with in these different scenarios. In the first one, if you're winning twice, then you're getting 3 points, and then you're getting another 3 points. 3 plus 3 is going to be 6. Then if you're going to lose twice, well, you get no points at all, so you have 0 points at the end. If you tie twice, then both of the games you're going to get 1 point. 1 plus 1 is 2. Then if you're going to win and lose, you're going to add 3 points and then add no points. So you have 3 points at the end. If you win and then tie, then you have 3 points and 1 point, which is 4. And lastly, if you lose and then tie, you get 0 points and then 1 point. So you end up with 1 point in total. So let's look at our answer choices. Is it possible to get 1 point? Yes, it is. That happens if you lose and you tie. So that's not our answer. Is it possible to get 2 points? Yep, that happens when you tie twice. Is it possible to get 4 points? Yep, that happens when you win and then tie. And is it possible to get 6 points? Well, yeah, that's exactly the first one. You're winning both games and you get a total of 6 points. So, like I'm seeing in chat, the answer is D, because it's impossible to get 5 points in 2 games. Let's check our answer. Awesome, it's 5.
All right, question 20. Alma wants to put one of the pieces shown in the middle of the picture so that a child in A is able to travel to B and to E, but not to D. She can rotate the pieces. Which 2 pieces could she use? So A is this one over here. That's where we start. We want to travel to B and E, that's these 2, but not no, B and E is these two, and not D, which is the one right across. So if we don't want the one right across, that means if we have a bunch of hexagons here, we don't want the one that connects two opposite corners. So this one connects two opposite corners. So I don't think we can use that one. Also, if we put any of the sides to A, I don't think we can get to either C or E. All right, for the second one, this one only allows you to go to the two ones on the side. So that means these two, or these two, or these two. But that doesn't connect all three of them. This one, that seems like it could work, right? Because B, C, and A look like they lie on an equilateral triangle. And if you draw out something like that, that could connect all of them. So maybe this could work, maybe. And then this one, again, that connects the opposite points and not the ones to E and C. So that doesn't work either. And this last one, again, connects opposite points. This one is like a combination of 1 and 4 and 2. You can't get to C and E. You can get to the ones on the side, though, B and F, but that's not what we're asked for. So I think the answer is choice 3. Oh, wait, no, there's 2. So choice 3 and choice 2 is B, C. Wait, what?
I think it's going to be,
help me a bit here.
Yeah, I think it's going to be 1 and 5, because if we remember, we can rotate these around, and if we have 1, then we can go from E and B. So that's going to be the straight line right here. And then we can also have that branch off to A, and it would also branch off to F. So you wouldn't be able to get to D. So that would mean 1 would work. And then if we put in 5, then we could make it like E to B, and then have it branch off at A and C. We would just have to rotate it a little bit. And that way they could go from A to B and E, but they would never be able to get to D. So I think the answer should be 1 and 5. What do you think about that?
I see. All right, well, let's check that. Yep, 1 and 5.
Yeah, awesome. All right, so let's go on to our second to last problem. We have 5 girls that are going to eat a plum. Lauren is going to eat 2 plums more than Sophie. Betty eats 3 plums less than Lauren. Claire ate 1 plum more than Betty and 3 plums less than Alice. And which of the 2 girls ate the same number of plums? So the way that we should do this is we got to break it down. And we can write out different equations for each one. So Lauren, I'm going to call Lauren L. And she's going to eat 2 more than Sophie. So S for Sophie plus 2. And then we're going to have Betty, who's B, is going to eat 3 plums fewer than Lauren. So that means it's going to be L minus 3. And then we have Claire for C, is going to eat 1 plum more than Betty. So that's going to be equal to B plus 1 and 3 plums fewer than Alice. And C is also equal to A minus 3. Now we want to figure out which of the 2 girls ate the same number of plums. The first thing I want to do is take a look right here where we have 2 different numbers equal to C. So C is equal to B plus 1. So that means that if we subtract 1 from both sides, that C minus 1 is equal to B. And if we add 3 to both sides on here, C plus 3 is equal to A. Now I want to plug this, which is equal to B, into here. Because if C minus 1 is equal to B and B is equal to L minus 3, then C minus 1 is equal to L minus 3. Now from here, all we have to do is add 3 to both sides, and we would get C plus 2 is equal to L. Now, from there, we're going to get L is equal to C plus 2. And remember, from the very first equation that we wrote, L is equal to S plus 2. We can just set these equal to each other. So C plus 2 is equal to S plus 2. Now, if we subtract 2 from both sides, that leaves us with C is equal to S. Or in other words, the number of plums that Claire eats is equal to the number of plums that Sophie eats. And let's check for that in our answer choices. And you see, it's answer choice B, Claire and Sophie. So let's bubble that in and check our answer. Looks like we were right. Claire and Sophie both eat the same number of plums.
All right, question 24. In the grid, the same number is hidden under the same color square. To the right of each row, the sum of the numbers hidden under the squares in that row is given. Which number is hidden under the black square? All right, so I think we can use equations again. So we have, all right, let me write it in here. This is gray, black, black, and this one is white. I'm just gonna write them as G, B, and W. This is G, this is B, this is B, this is G, this is G. All right, so we have three variables, the number of grays, the number of blacks, and the white number. And then we have three equations, right? Three equations are here. So let's write that. G plus 2B, that's the first line, is equal to 34. G plus B plus W is equal to 32, that's the second line. And B plus 2G is equal to 26. And that is the third line. All right, so let's see what we can do here. See, if we if we multiply the second equation by 2, then we get 2 B's, 2 G's, 2 W's, and then we can subtract these, because if you subtract one from the other right now, then you'll get negative, and we don't want negatives right now. So let's scroll this up to the side. All right, let's just keep our equations clean then right here. So this gives 2G plus 2B plus 2W is equal to 64. If we subtract this one from the first one, then we get G plus 2W is equal to 30, right? 64 minus 34 is 30. And if we take the second one and subtract the third one, we get 2G minus 2G is 0, 2B minus B, that's B, plus 2W is equal to 64 minus 26, that is equal to 38. So, these are some obnoxious numbers. We have 2 G's, 3 B's, and 4 W's.
What I did was actually really similar, but instead of going through and adding and subtracting the equations, I set G equal to something and plugged it back in to our third equation. And that didn't give us terrible numbers.
Oh, okay. For which equation did you plug in?
I used the first one, so G plus 2B equals 34, to figure out that G is equal to 34 minus 2B. And then I plugged it into our third equation, and that's how I figured out B from there.
All right, so G plus 2B is 34, so that gives G equals 34 minus 2B. Oh, okay, so then, yeah, we plug into the third one, we get B plus 34 minus 2B is 26, and then now we have all B's, so that's good. B plus 34, or 2 times this. So 2 times 34 is 68, 2 times negative 2 is negative 4, that's 26. And b minus, okay, that's common. B, I'm going to try again. B minus 4b is going to be negative. So how about we move the b's to the left, and then we can move this 26 over there. That means we get 3b on the right, and then 68 minus 26 is equal to 42. That's a good number. 42 over 3 is an integer. That's 14. All right, so we know what b is, and if we go back to the question, it asks for the black square, so that's good. So we already figured out what b is 14, so that should be, or no, wait.
Actually, before we check, I think that the colors got swapped on our screen. So the ones that we see as the black square are actually the white square, and the one we see as the white square is the black square. So it should say, what is the white square for us?
Oh, okay. I guess we continue then. White square. All right. Anyways, we have b. We have b plus 2g. So if this is 14, then 2g is equal to 26 minus 14, which is equal to 12. So that gives g is equal to 6. And then finally, we have this big equation, g plus b plus w equals 32. We have a 14. We have a 6. That adds up to 20. 32 minus 20 is 12. Let's go back. Is that an answer choice? Yes, it's an answer choice. It's choice D. And let's check that. Yes, it's choice D. All right. We need to get some better colors for these.
All right, awesome. I actually think that was our last problem of today, but we're not done yet. So maybe, let's see, does anyone have any questions about any of the problems we've done? And we can kind of go back and take another look at them. So we're taking a look at chat now, and if there was a certain question that you saw that you didn't understand, then we can go back to it. Okay, I see someone saying the last one. So let's take a look at that again. Now, my guess is the confusion is because the colors aren't really coming through to you guys, and you can't really see what the blocks are. Is that correct? Okay, I think that is the problem. So yeah, people are saying it is in chat. So you can't see the colors, but what me and Kevin have on our screens is this one at the top left is G, which is like a gray square. Then the next two are black. And then if we go to the next row, this is a gray square, this is a black square, and this is a white square. Then on the last row, there's one black and two gray. So that's kind of what these letters in here represent. Okay, now seeing some understanding in chat, which is great. And then what Kevin did from there was he added, so the value of the gray square plus the value of the two black squares is equal to 34. Then the value of a gray square plus the value of a black square plus the value of a white square is equal to 32. And lastly, the value of a black square plus the value of two gray squares is equal to 26. And that's how Kevin got these three different equations. So now that we've kind of clarified that, does anyone have a question about it still, or should we go on to a different one? Okay, it looks like people do understand, which is awesome. Kevin, do you think there's another problem that we might want to go back and highlight? I think you're muted.
Maybe this one, maybe question 20. All right, so let's go through how Jesse did it again. So we can take these four and just kind of shove it on here and see which one works. First one, we can do something like, which one was it? Sorry, Jesse, do you want to explain this one? Because I forgot how you did it.
Oh, yeah, sure. So what I looked at was, remember, we want to connect E, B, and A, but we can't connect D to it. So what I looked at was the first thing, looking for the straight line to connect E and B. So if our answer choices don't have a straight line in them, then it can't connect E and B and it won't work. So when we do that, we can immediately get rid of answer choices 2 and 3 because there's no way to connect E and B in there. And then when we look at that, we know that we need something branching off of the side right here in order to get to A. So if we look at it, there's something branching there, something branching there, and something branching there. So it all works on all of them, and A is good. The last thing that we need to check is to see which of these 3 would give us B. So let's draw it in. If we have answer choice 1 put in there, and we want to connect the straight line between E and B, then we have it like this. And then we have these 2 branching off of the top, and because we're rotating it, it's now branched to F and to A. So that's kind of how A would be positioned in there. Okay, and now we can go to 4, and if we use the straight line between E and B, then we have this line here, and there's something branching off in 2 different ways. So one is branching off to A, but then we have the second one, which branches off to D. And our question said that we can't go to D, right? So that means that answer choice 4 doesn't work. And just based on the fact that we have 2 remaining, we know those are our answers, but we should still check 5 anyways. So if we put our straight line to E and B, then we have something branching off to A. That leaves us with this one little section here, and that would go from right here to C. And that satisfies our requirements. So
yeah, I understand what I didn't do because I spent the whole time thinking that it was A to C and E instead of A to B and E. So yeah, guys, remember to read the question correctly.
Okay, so we have those problems down. I think those were probably the trickiest problems on that test, and it makes sense because there's some of the higher number problems, and it does get harder as we go on. So does anyone have another question they might want to go to? Something that we could clarify any part of? Okay, more people want the blocks. So Kevin, do you want to go ahead and talk more about that block question? Oh, there's 2 block ones. I'm guessing it means the 3D block shape.
Oh, okay. I'm assuming it's this question. All right, so the question is saying that we have these 3 types of blocks. We have an L, we have a gray, and then we have a singular block. And again, the colors are a little bit weird, but this one right here, you can see that these 2 grays are the same. And this one in the middle is another one. And this L shape is right there. And we have these 4 over here are the singular blocks. This one is a singular block. These ones behind are also singular blocks, except for this one right here in the corner. This yellow one, the one that I circled, this one. Or I should probably not use yellow. Yeah, the blue one. That one right in the corner, that is actually the same color as this L block. So on the test, if you ever have these kind of shaded gray black questions, be sure to look at the colors really carefully. So we have one L right here. We have another L, which is this one that's hidden right there. So we got 2 of these. And then for the gray ones, there's one right here. And then there's one right here, the one in the middle. Even though you only see 1 block of it, you can tell that the one in the middle is not part of this block because that is a straight line. And if these 4 are all part of the same, well, that's not a straight line. So that's not going to be the same one. So we have 2 separate blocks of the gray color. And then what we want to find is the number of small cubes. Well, we can't directly go and count them because there are ones that we can't see. So what we have to do is find the total number of cubes, subtract the number that we have right here that we can see and can tell, and that leaves us with the number of small cubes. A cube has length equals width equals height. And you can see that the length and the width are all 3 blocks. So that gives us 3 times 3 times 3, which equals 27 blocks. So that is how many blocks total. If you cut both of these into small ones like this one, then there will be 27 in this 3 by 3 by 3 block. And then we just have to count how many total blocks we have with the 2 L's and the 2 gray ones. As we said, we can split this one into 5. Something like that, that, and that. See, 1, 2, 3, 4, 5. So this is 2 times 5, which gives 10. This one you can split into 3 because, as you can see here, it takes up a whole length. So that's 2 times 3, which is 6. And if you add them up, that gives you 16 total blocks that are either L or gray. So we have 27, we have 16, and we just need to subtract them to get the number of small cubes. So 27 minus 16 gives us 11 of the small cubes. Yeah.
Awesome. Yeah, that was a really good way of going through that one, I think. So we still do have a little time left. Does anyone have questions about a different problem that we might want to go through?
Actually, I want to talk about the first one that I did about the boxes.
Okay, that'd be really cool.
Ignore that. Let's see. Where is it? This one. All right, so when I looked at the answer, I can tell why it was 5 because everything that's on top of anything that's on top of this box, then you're gonna have to open it. But at first, when I was thinking about it, I was like, what if you remove a bigger box that like holds a smaller box on top that is like fully on it and isn't like an edge off? Like I was thinking about these two because like this small one is fully on this one. So if you just take these 3 out, then you may be able to just take this big one and then you can count that as taking 1 box. So I was just thinking about that, but I guess that's not what they're asking for, but yeah.
I think that'd be a pretty funny way to kind of like get around the rules and like figure it out. I think if this was like a real life scenario and I had to move this box, what I would try and do is move the clothes box so it's right underneath the stuffed animals, just so it's like positioned perfectly on top of it. And then I kind of play Jenga and kick the train box out from under it. And that way I wouldn't have to pick up any boxes.
That's
But
smart.
unfortunately, we can't do that in the problem. Well, if we don't have any other questions, there is another one that I'd like to talk about, and it was that football game problem. So we can actually talk about the number of ways to set the games between between the different teams. So the problem tells us that we have 3 football teams, right? So we can call them Team A, Team B, and Team C. And we said that there's going to be each playing 1 game against the other 2. So if we want to figure out the total number of games there are, then the first thing that you might think to do is just say, oh, 3 teams, each playing 2 games. 3 times 2 is equal to 6, right? But that's not the total number of games played because each team plays 2 of those games. So it's actually 3 games played in total, and we can talk about why. So if any of you guys have any kind of combinatorics introduction, then the first thing you could do is 3 choose 2, and that's the number of ways out of the 3 teams to choose the 2 of them. So 3 choose 2 is going to be equal to 3. So that's one way you get 3 games. Or something else we could do is say, well, if for each game, there's 2 teams that are going to play, right? So 3 times 2. 3 is going to be the number of times to choose your first team, and 2 is the number of ways to choose your second team, because you could choose A, B, or C first, and then you could choose the other 2 for the second one. But then remember, we have to divide by 2, because picking A and then B is the same as picking B and then A. So that also gives you 3. So it didn't really help with the problem, but it's pretty cool to see how you can figure out the number of games that are going to be played in a tournament. And I don't know if anyone here is a sports fan, but if you are, you could use this in real life.
Yeah, see how many games are played in a round robin tournament.
I think I saw in chat someone wanted to go over question 24 again. So let's do that. Oh, question 24 is the square problem again. So for the people who don't understand it, what part of it are you confused on? I'll give you some time to send in chat what you're confused about. And in the meantime, okay, confused about all of it. All right, so I think I went through it last time. Kevin, do you want to go through it again this time?
Oh, sure. All right. All right. So we have that the sum of the numbers in each row adds up to the numbers here. And we have three different colors. We have a gray, a black, and a white. And as Jesse said, in the end, we're going to have to switch the black and white because actually the black is the white and the white is the black. But we can just go off of that now. So we can make three equations and we have three variables. So we should be able to solve the problem. So we have a gray and two blacks, which gives us the first equation, which is g plus 2b is 34, which the 34 is right here. We have the g plus b plus the w gives us 32, which is the second one. We have b plus 2g, it gives us 26, and that's the third equation. And then what we can do is, oh wait, I erased all of it, didn't I? Let me uncover it. Right, that's right there. So we can take g equals 34 minus 2b. How do we get that? We take this third equation, or no, we take the second equation, and then we isolate g so that we can substitute it into the second equation. So how do we isolate it? We take 2b and we move it to the other side. So that's how we get this. And then we substitute g into the third equation. So we have b plus 2 times all of this down here is equal to 26. Why is this good? It's good because then we have a single equation that only contains b, which means that we can finally solve for a variable. And we do that, we get b equals 14. And then again, we can plug it back into this equation. We get that g is equal to 6. And then since our second equation says that all three of them add up to 32, then if g plus b is equal to 20, then that means w plus 20 is 32, which means that w is 12. So that's what we were solving for, which means that the answer is 12, I think. Yeah, D.
All right, awesome. So I think in the last 3 minutes, someone said they had an issue with or they had a problem with the house problem. So let's try and find that one again then. Kevin, do you remember what number that was?
I do not remember a house problem actually. Let me go back.
Yeah. Let's see who said that. I think it was Lucas Wang for the house. Oh, the roads. Are the roads the houses?
What roads?
Did the roads connect houses? Is that what it was? Yes, it was the roads. Okay. Go back to that one again.
Was it the first one? The one about the laser?
It was question 20. The one with like rotating the paths.
Okay. This is,
yeah, it doesn't say that they're houses, but you can, if you look at the picture, they look like houses. So I think that the most important part of this problem is to see that we want to connect these two houses and A. So we need some kind of way to connect these three, but we have to make sure that D can't access them. So what I did was, just again, the first thing that's the most important is connecting E and B. So E and B is a straight line, and the two of them that don't have straight lines are 2 and 3. So those aren't our answers. And then we know that we have to go to A, but we can't go to D. So if we draw this shape like that, then the one thing that we have is, oops, sorry about that. Okay, so yeah, if we go here, then if we have a house that connects E, A, and B, but it also connects D, it looks like this. Now we can just look at our answer choices and see that that looks exactly like this. So this one won't work. And there's two pieces that are going to work. So that means that the two remaining are our answers. All right. So Kevin, do you have anything else to add to that one?
No, I think that was a good explanation by you to me.
Awesome. So I see it is 9 o'clock, which is the scheduled end time of this event. So do we have anything else any questions left before we let you guys go? Okay, no more questions. So in that case, bye everyone. Thanks for coming.
Yep, thank you guys.